Okay, so continuing with section 5.2, we are going to talk about now, we're going to focus on similar polygons. So if you go back to the transformations that we did, the rigid transformations, which kept things exactly the same but in a different orientation, were translation, rotation, and reflection. And then the transformation that we mentioned and said we would go back to was a dilation. And so a dilation gives you an image and a pre-image, so whichever one is the image and the pre-image, that are the same shape, but a different size because they have been enlarged or reduced, okay? So that's really kind of the definition of similar polygons. Similar polygons are polygons that have the same shape but a different or congruent size. So they keep their shape from having congruent angles, but they get their different size by having proportional sides. So that means that there's a scale factor between the two sides of the triangles, okay? So if you look at this figure, this isn't great because it marks all these angles congruent. They really aren't, but you can see that angle X is congruent to angle X. We're going to add some arcs so that this is accurate. Angle Y is congruent to angle Y, and angle Z is congruent to angle Z. Okay, so because we've got three pairs of congruent angles that correspond, and then if we knew that our sides were also proportional, we would know that this is similar. So if this is similar, then this short side corresponds to this short side. So A over P would have the same ratio as B, the long side, over Q, which would have the same ratio as the middle length C over this side V. Okay, and so make sure that you set up your proportion consistently where you do, I did big triangle over little triangle, big triangle over little triangle. You could flip it, but just make sure you start with the little triangle each time then. So let's take a look at some of these examples. In number 11, it says, oh, and this is important, this indicates, that's the symbol, just the tilde by itself is a symbol for similarity. So it says some polygon, ABCD, is similar to polygon PQRS, and because there's 4 vertices and 4 points, we can assume that it's a quadrilateral. What is the measure of angle R and the length of segment AD? So we know that these two polygons are similar, and from the similarity statement we can see what corresponds. So we talked about these with congruent statements, and it's the same way. So if we want to look at angle B, we know that these figures are similar, then angle B corresponds to angle Q, and we just said in similar figures the angles are congruent. So angle B would be congruent to angle Q. Or if we want to look at segment CD, it corresponds to segment RS, and we know that those sides have a ratio that is proportional to the comparison of, say, BC over QR. Okay, so let's take a look at this. So what is the measure of angle R and the length of AD? So the first thing we probably want to know is, what does R correspond to? And so R is the third angle in the similarity statement, so it corresponds to angle C. And let's look at our picture and see what we have there. So angle C is 70 degrees, which means that angle R is also 70 degrees because similar polygons have angles that are congruent. Okay, so the measure of angle R equals 70 degrees. Now for side AD, we have to set up a proportion to solve for it. So we know that our sides, we've got this side QP and this side SP, and then we've got this side AB. We know that our sides are proportional, so we need to set up a proportion. We know we're going to use AB, so we're going to do AB because we have it, so we want to use it, over, and it needs to correspond, and it corresponds to PQ. So we're going to do AB over PQ. So I did big figure over little figure for corresponding sides, and that's going to be equal to, and then on my little one, I have SP, which is my first and my last, and I'm trying to find AD, which is my first and last. So that's good because they correspond. So my big will be AD over my little, which is PS. And then I'm just going to substitute the values in. So I'm going to do AB equals 10 over PQ, which is 6, and that's equal to AD, which is X, that's what we're trying to find, over the sine PS, which is 5. And we'll cross multiply and solve for X. So 50 equals 6X, and when we divide by 6, let's see here, 6 goes into 58 times, so AD equals 8 with a remainder of 2/6, which reduces to 1/3. So AD is equal to 8 1/3. So, okay. In example number 12, it asks, are the figures similar? If so, write a similarity statement. So in order for them to be similar, remember the definition says that they have to have congruent angles and proportional sides. So the first thing we want to check for are congruent angles. So we have angle L is congruent to angle Q. Angle M is congruent to angle P. And by the third angles theorem, if two pairs of angles are congruent, then the third pair also has to be, because they have to add up to 180. So there we have our 3 congruent angles, so that's good. The next thing we need to do is check if the sides are proportional. So you have to check both things, congruent angles and proportional sides. So I'm going to do the big over the little, and I'm going to set up my proportion and check to see if it reduces to the same thing. So I'm going to start with my big triangle, and then start with my shortest side. So 10 is the shortest side, and it's going to correspond to my shortest side, which is 4. My medium length side is 15, and it's going to correspond to the medium length on this triangle, which is 6. And then 20 is my longest side, and that's going to correspond to 8. And then this has to reduce. Each one of these has to reduce to get the same ratio in order for these to be proportional. So if I divide this by 2, I get 5 halves. Divide this by 3, I get 5 halves. Divide this by 4, I get 5 halves. And so because my sides are proportional and I get the same ratio each time, my triangles are similar. And I can say triangle LMN. I can put the first triangle in any order I want. Is similar to triangle. Now here's where you have to be careful. You have to do corresponding parts. So L had 1 arc, so it corresponds to Q with 1 arc. So triangle LMN is similar to triangle Q, and then M corresponds to P with the 2 arcs, and N corresponds to R. Okay, so I showed my similarity statement. I checked for my 3 pairs of congruent angles. And I showed my proportions, and then I wrote my similarity statement. So take a look at 13 and then check my notes online and see what you come up with. Okay. And then number 14, you can go ahead and do the same thing. So take a look at that, try that, and then check my notes on Classroom. So that's it. Bye.